number 17, example 19, or number 17 in the book. Okay, so if y'all will pause just for a second, let's go read that problem. I'll write down some key information and we'll come right back. Okay, so as we look at this last problem, it's talking about the demand of computers after so many months, T specific months. And they give us an equation. Obviously they're doing capital D for demand. So the demand after T months is going to be 2,000, then minus this exponential part right here. And let's look at this exponent. You know, if we just focused on the 1500 e to the negative 0.05 t, that looks like that's basically in our main equation for an exponential growth equation or an exponential equation. And look, the 1500, that's kind of like our initial quantity, remember? And then that number attached to our variable up here in the exponent, that's our growth constant. Well, since it's negative, look what's happening. The demand is decreasing. That's showing us right there that the demand is definitely going down because it's negative. And so that kind of makes sense. You know, something's new to the market, everybody wants to have it, but then after a while, the demand does go down. It goes down by about, if I convert that to a percent, it's going to be by 5% per month. Okay, because obviously T's in months, it's going to be 5% per month. Okay, so let's go to the question. What it wants us to do is we want to graph this equation, and then after looking at the graph, we want to find what's the demand after 1 month, after a year, after 2 years, after 5 years. Okay, so we want to find the demand. Let's see, let's write it like this. I'm going to do actually the chart first. I'm going to find this information, but that's going to help us to graph it, you know. So I'm going to give a t value, and then we'll look at the demand over here. Okay, so this says, what is the demand after 1 month? Okay, and this has got to be in terms of month. And the next thing they want to say is after 1 year. Well, 1 year obviously is 12 months. After 2 years, which is 24 months. And then after 5 years, which is 60 months. Okay, so when I go in there and I find D of 1, just go into my equation, go 2,000 minus the 15,000 e to the negative 0.05 times 1, and let's get a value coming out. Okay, so when I do that myself, when I plug in D of 1, just, 2,000 minus 1,500 times your second ln e, and then up there in that exponent, just keep it all in one parentheses, so negative 0.05 times 1, I get roughly about 573. Okay, and then when I go up there, and again, if I want to try it for now, when we're looking at more of 1 year later, so for 12, then I get the demand to be, to the D of 12, I get the demand to be about 1,177. I'm kind of rounding a little bit. And when I, again, after 2 years, then we get a demand of, looks like 1,548 computers. And last but not least, after 5 years, when we look at that, I get a demand of 1,925. Okay, let's just for kicks, let's bump it up. That last thing they want us to do was for 5 years. What if we wanted to do it for 10 years? Okay, so in other words, after 120 months. I want to find that for just 1 second. So I want to show you guys something. It comes out to be, so after, that right there is 10 years. This is 5 years. That's 2 and that's 1 year. So after 10 years, or 120 months, the demand is 1,996. Look what's happening here. In the first month, it was 573. 11 months later, it pretty much more than doubled in how much the demand was. Then after that, didn't really go up a whole lot, maybe 400. Up there, not so much. Look right here. And basically from year 5 to 10, over 5 years, all it went up was just from 1,925 computers to 1,996. Okay, so this is really what's going to happen, is that Part B. Part B says, at what level is the demand of computers about to stabilize? Well, what number is this getting really, really close to? It's 2,000, which, look, that was our very first number in the equation. Because what this equation is telling you is you're starting at 2,000 and you're subtracting off values from there. But you're always starting at 2,000 and going to subtract something from it. So I guess you can say stabilize. Let me just check. stabilize at about 2,000 computers. Okay, and then again, if you wanted to see the graph, it's basically what? It's basically going to the initial amount, about 1,500, and let's say that's 51. Let's go by. There's 500, then 1,000, and then here's 2,000. We're going to start right here at about 500 computers initially, and then the graph just kind of curves up and gets pretty flat just right here, right around 2,000. And you can just see that by plugging it in. And how I got that 500, typical y-intercept. When you want to find the y-intercept, I just plugged in 0 for t. So it's basically y is equal to 2,000 minus 1,500 e to the negative 0.05 times 0. Well, that just takes that all away because that's just a 1. So 2,000 minus 1,500 was 500, and that's how I got that one just initially. And there you go. So there's a good idea of basically how to use the whole concepts of log functions and exponential functions into the real world.